In this video, we're going to do a limit and derivative question. So we're going to do the limit as x goes to 0 from the right of the derivative with respect to x of cosine of x times ln of x. Also, don't forget to subscribe and turn on notifications so you don't miss a video. Okay, the derivative of cosine of x times ln x. How do we do this? So the derivative cosine of something is negative sine of that something, so that'd be x times ln x, times the derivative of the inside. So the derivative of x times ln x. How do you do that? So we'll do the first times the derivative of the second. The derivative of ln x is 1 over x, plus the second, which is ln x, times the derivative of the first, which is just 1. So this will be negative sine of x ln x times 1 plus ln of x. Okay, so now we'll do the limit as x goes to 0 from the right of that derivative. So that'll be negative. So the negative can go in the front. We'll have sine of x times ln x, all multiplied by 1 plus ln of x. Okay, so one thing we'll need is the derivative of this, which is the inside of sine of x ln x. So how do we do the limit as x goes to 0 from the right of x times ln of x? Okay, if you just plug it 0 plus in, you get 0 times ln of 0 plus is minus infinity, so you can't work with this. So that means we have to put one of the terms on the denominator. So let's pick x because it's easier to differentiate. So we're going to have ln x on the top. Now if we move x to the bottom, we'll be left with 1 over x. Okay, so this is the bar, the fraction bar. So plugging 0 plus into the top, you get negative infinity. Plugging in 0 plus to the bottom, you get 1 over 0 plus is defined to go to infinity. So now we can use L'Hopital's rule. Okay, so this will be the limit as x goes to 0 from the right. So L'Hopital's rule says we do derivative over derivative. So we have the fraction bar still from before. The derivative ln x with respect to x is 1 over x. The derivative 1 over x, which is the denominator, is negative 1 over x squared. Okay, now we're going to multiply x squared on both sides. That's just multiplying by 1. Okay, x squared over x squared will cancel. X squared over x will cancel one of the terms, so instead of x squared, we'll be left with just x. But now we can take the limit of x going to 0 plus of just x on the top times negative, but that's just 0. Okay, good. So that means that this part goes to 0. We know that sine of 0 is 0. 0 times 1 is 0, so this part goes away. So we can really rewrite this as sine of x ln x times ln of x because the other part goes away. Okay, good. So now let's plug in, this is equal to, so let's plug in 0 plus. So we're going to get 0 from this term, and then here we're going to have negative infinity again, so this is not good. So now we can move one of the terms to the bottom. So we're going to have the limit as x goes to 0 from the right. On the top we'll have sine of x ln x because the derivative of 1 over ln x is easier to differentiate than 1 over sine of x times ln x. Okay, so we're going to have it all over 1 over ln of x. And this is the fraction bar now. Okay, so again, we're going to have sine of this will go to 0. And 1 over ln of 0 plus is 1 over negative infinity, which is defined to be 0. So now we can use L'Hopital's rule again. So now this will be the limit, the negative sign in the front, times x goes to infinity, to 0, plus, sorry. Okay, we're going to have the derivative of the top part will be the derivative sign, which is cosine of what's left in, multiplied by the derivative of the inside. But we found the derivative of x ln x is 1 plus ln x. Okay, all over the derivative of 1 over something. So let's just look at this. The derivative with respect to x of 1 over u. You can write this as u to the minus 1 and then do the power rule. But so this will just be negative 1 over u squared times the derivative of u with respect to x. Okay, so this will be negative 1 over ln of x quantity squared times the derivative of the inside function, which is 1 over x. Okay, good. So now we can see the negative from the limit outside the limit, and the negative here will cancel. we can move x to the front, the top, because x times 1 over x will cancel. And then, so what will we be left with? So we can move ln of x quantity squared to the top. So we're going to have the limit as x goes to 0 from the right of x times 1 plus ln x times ln of x quantity squared times cosine of x times ln of x. Okay, good. So what do we see here? So let's think about this. This multiplied by this. Okay, cosine of x times ln x, as x goes to 0 plus, the inside will go to 0. So that means that this in total goes to 1. Okay. But then x has a 0 here. So 0 times 1 is 0. So this can really go away. So we're going to be left with ln of x. Ln of x, we have an extra ln x, times ln of x quantity squared is ln x cubed. So let's rewrite that. So we have x times ln x cubed times cosine. So we're going to have times this part, which is cosine of x times ln x. Okay. So let's plug in 0 plus here. So 0 plus, again, as we said, this goes to 1. But if that's 1, that's just a constant term, but 1 can go away. So we can get rid of this. And now we'll be left with the limit as x goes to 0 plus of x times ln of x cubed. So let's look at this. We have the limit as x goes to 0 plus of x times ln x to the third power. Okay, we're going to write this as the limit as x goes to 0 plus ln x cubed on top all over 1 over x. As x goes to 0 plus, the top will go to, so we're going to have minus infinity cubed, but that's still the negative sign, and then all over. Okay, as we said before, as x goes to 0 plus, 1 over x goes to infinity. So this is a infinity positive term over infinity. So we can do L'Hopital's rule again. So leaving us with the limit as x goes to 0 plus the derivative of ln x to the third power. So we can think about this as the inside function. So this would be u cubed. The derivative of u cubed is 3 u squared. So that would be ln of x quantity squared times 1 over x. That's the derivative of ln x. All over minus 1 over x squared. Again, we can move x squared to the front, top. X squared over x squared will cancel. X squared over x will turn to x. Okay, so we'll be left with negative 3 on the outside. So negative 3 times this limit. So that's x times ln x quantity squared. So you can see that if you do this again and again and again, this 3 will go to 2, will go to 1, will go to 0. And finally, as x goes to 0 plus, you'll be left with a constant times the limit as x goes to 0 plus of just x, which is 0. And that is the answer to this question, and that's the end of the video. Hope you liked it, and thanks for watching.